Okay, let's continue and extend some of the ideas that we've learned from the unit circle to points that are outside of the unit circle. So for example, find the sine, cosine, and tangent of theta in this picture. Well, what we're going to need to do is make a right triangle. So from the point that we're given, -3, 4, I want to draw a line to the x-axis in such a way that it makes a right angle. So I'm going to drop it down right there. And then I'm going to label that as -3. I know the length of a triangle, you're thinking a side can't be negative. I'll explain more in a minute. And then this will be 4. And then we'll use the Pythagorean Theorem to find the hypotenuse. 3 squared plus 4 squared, and this winds up equaling 5. What's important to understand is if I took this triangle and I flipped it over the y-axis, see if I can do that. Finding the sine, cosine, and tangent, let me draw an arrow here. Finding the sine, cosine, and tangent of this angle here, which happens to be the supplement of the theta we're talking about. Theta went from the positive x-axis to this blue segment here. So what's left over here will be 180 minus whatever theta is. Well, that's the same angle as right here. And the sine, cosine, and tangent of this angle are going to be very closely related to the sine, cosine, and tangent of this bigger angle here, which takes us into the second quadrant. The only difference is the sine of theta of this new angle here, the supplement of theta, will be opposite over hypotenuse. So in this case, 4 over 5. But the cosine of this angle here would be positive 3 over 5 instead of negative 3 over 5. So we're finding the sine, cosine, and tangent of theta by drawing this triangle in the second quadrant, and the angle in that triangle is really the supplement of theta. So it turns out that the sine of an angle equals the sine of its supplement. The cosine of an angle is equal to the opposite of the cosine of its supplement. And then the tangent of the angle, similarly, will be the opposite of the tangent of the angle of its supplement. Okay. Hopefully that didn't confuse you too much. So here's what we do. We take that point -3, 4. We make a right triangle by drawing a segment to the x-axis, forming a right angle. And now we're just going to go ahead and do what we've done early on with sine, cosine, and tangent. The sine of theta we know is opposite over hypotenuse. So we're using this angle now in here, which is the supplement of that one. This angle here, the opposite leg is 4. The hypotenuse is 5. So we get 4 over 5. And then the cosine is going to be the adjacent leg, which is -3, over the hypotenuse, which is 5. So cosine of theta, and I'll put the negative out in front of the fraction, -3 over 5. And then the tangent of theta will be opposite over adjacent, and that would be the opposite is 4, and the adjacent is -3, so 4 over -3. Once again, I'll put the negative out in front, -4/3. And there you have it. Sine, cosine, and tangent of theta. Let's try another one. It's worded a little differently, but it's essentially the same type of problem. The point -5, -12 is on the terminal side of an angle in standard position. Find the exact values of the 6 trig functions. So step 1, we always want to plot this point. And so we're going -5, -12. Let's just pretend that's over here. That's -12. That's -5. So what I'm going to do is I'm going to connect that to the origin, make a perpendicular to the x-axis. Now I have my right triangle. And let's label my sides. So this is going to be -5. This one's -12. And then use the Pythagorean Theorem to get the hypotenuse. 5 squared plus 12 squared equals c squared. You'll wind up getting this equals 13 exactly. So there's our right triangle that we're going to use, and this is the angle that we're referring to, the angle at the origin, connected to the origin. Now theta really represents the angle that goes all the way around to here. Okay, but with the negatives for my sides, it's going to be the same as using this acute angle in the right triangle. So let's go through them. We've got sine of theta. And let's draw my arrow again. So the sine of theta is going to be opposite over hypotenuse, negative 12 over 13. So let me go ahead and do the cosecant, which is the reciprocal function of sine, and that'll be negative 13 over 12. And we'll do the cosine of theta. Cosine is the adjacent over the hypotenuse, so the adjacent leg is here, negative 5. Let's get that out of the way. Negative 5 over the hypotenuse, which is 13. So we get negative 5/13. Its reciprocal function is the secant, so we might as well take care of that one. The secant then will be negative 13 over 5. And finally we'll do the tangent. Tangent is opposite over adjacent, so we get negative 5 over negative 12. I'm sorry, negative 12 over negative 5. The negatives cancel, so we get 12/5. And therefore our cotangent is 5/12. And so now we've got the 6 trig functions of that angle. All right, different type of problem. In which quadrant or quadrants is the sine positive? And where is it negative? What about the cosine? What about the tangent? Let's look at our quadrants for a little bit. And now that we're pretty familiar with the unit circle, we can use that to help us. We know that the sine represents the y value of a coordinate of any point in the first quadrant. And the x coordinate is the cosine. So with that in mind, let me write that over here. The sine of an angle theta equals the y coordinate in the unit circle, and the cosine is the x value. And we know the tangent is equivalent to sine over cosine, so that's y over x. So in the first quadrant, everything is positive. So the sine is positive, the cosine is positive, and the tangent is positive. So all 3 of them are positive in the first quadrant. Let's just write A for all of them. In the second quadrant, the sine is still positive, but the cosine is negative, because x is negative to the left, and therefore the tangent, which is sine over cosine, will also be negative. So in the second quadrant, only the sine is positive. Go down to the third quadrant. Now here the sine is negative, the cosine is also negative, and that would mean that the tangent, sine over cosine, negative over a negative, would be a positive. So the tangent is the only one that's positive in the third quadrant. Put a T here for tangent. And then lastly, in the fourth quadrant, let's see, the sine, the y value, that's negative. The cosine, that's the x value, that would be positive. And therefore the tangent, sine over cosine, is going to wind up being negative. So only the cosine is positive in the fourth quadrant. So I'll put a C there. So what we have, these letters represent which functions are positive in the respective quadrants. So in the first quadrant, all 3 of them, sine, cosine, and tangent. In the second quadrant, only the sine. In the third quadrant, only the tangent. And in the fourth quadrant, only the cosine. So a way to maybe help remember this, all students take calculus. All students take calculus. So that can help you remind. Now, how is that going to help us? Well, let's look at another problem that'll use that information. Find the 5 trig function values of theta if the sine of theta is negative 3/7 and the cosine of theta is greater than 0. All right, so first of all, let's look at the sine of theta is negative. Negative 3/7. where would that happen? Well, that could happen down here or here, because the y value is negative. So I'm not sure, are we talking the third or fourth quadrant? But then we get this other piece of information that says the cosine is greater than 0. Well, that happens either here or here, because the cosine is the x value. So the only overlapping quadrant we've got to be in the fourth quadrant for this problem. For the sine to be negative and the cosine to be positive, that only happens in the fourth quadrant. So now I know where I'm at. So now I'm going to go ahead and plot my point. So -3/7. So that tells me that I'm going -3 in the y direction. And I'm not sure in the x direction. Maybe I should draw this a little bigger. We'll zoom in. Put -3 over here. So we have some point over here. And I know the hypotenuse is 7. And so let's make a right triangle. So from this point, let's go perpendicular to the x-axis to make a right triangle. That side's 7. This side's -3. I have to figure out this side. And then I can get my cosine, tangent, cotangent, etc. So I'm going to have to do the Pythagorean Theorem. X squared plus -3 squared, or 3 squared, equals 7 squared. So x squared plus 9 equals 49. X squared, if I subtract 9 from both sides, take the square root. Now I know the x is a positive value, so I'll take the positive root here. So x is going to equal the square root of 40, although that's 4 times 10, so I can rewrite that as 2 times the square root of 10. And so that's going to be the length for this side, 2 root 10. So now I have my right triangle. And I know where it's at, and that helps me figure this out. What some students would like to do is just draw a right triangle like this and say -3/7. And then they automatically just fill in this using the Pythagorean Theorem. But what would happen if we were actually in the third quadrant instead of the fourth? Then the x would wind up being a negative value, not a positive value. So I highly recommend you always draw an x and y axis and put the point in the correct quadrant. And that'll make sure you label your legs as positive or negative in the correct fashion. All right, so now we're ready to go ahead and write our answers. Now we know the sine, they already gave that to us, but I'm going to put it up here. The sine is -3/7, so I know the cosecant will be -7/3. From my picture, the cosine of theta is going to be 2 root 10 over 7. So the secant, I'm going to have to do a little work on this one, is going to be 7 over 2 root 10. And we don't like to have square roots in the denominator, so let me rationalize that. I don't have to multiply by the 2. Oops. I mean, I could multiply by 2 root 10 top and bottom, but then I'm going to have to reduce more. So I wind up with 7 times the square root of 10 over 2 times 10, which is 20. Okay, how about the tangent? I'm going to have to rationalize on this one again. So the tangent is opposite over adjacent, so I get -3 over 2 root 10. And I'm going to fix that in a minute, but before I fix that, let me jump to the cotangent. That'll save me some work down the road. When I flip that, I get -2 root 10 over 3. No work needs to be done with that one. On this one, though, multiply by root 10 over root 10. So for our answer here, we get -3 root 10 over 20. And there we've got all the trig functions for that particular angle based on that point graphed in the fourth quadrant.